Hello everyone, welcome back to another kinetic tutoring episode. Today we're taking a look at AP Chemistry once again. Today we're focusing on 1.4. So let's get straight into it. Problem 1 asks us to calculate the percentage of NaCl by mass in the mixture provided. So, what you're going to want to do is you're going to divide the mass of NaCl by the total mass of the mixture. 6.17. Here we go. So that's how you would find the mass of NaCl. So let's do that really quickly. 2.75 divided by 6.17. This gets you 0.4457 and multiply that by 100 to get 44.57%. Now it asks us to calculate the percentage of Na by mass. So what we're going to want to do here is first find the percent composition of Na in NaCl. So let's do that really quickly. 22.99, which is the mass of NaCl. 22.99 divided by, or the mass of Na rather, divided by 22.99 plus the mass of chlorine, which is 35.45. Let's find, and then you multiply that by your 44.57%. So let's see here. You get 22.99 divided by 22.99 divided by parentheses 22.99 plus 35.45 and parentheses gets you around 0.3933. So multiply that by 44.57. You'll get around 17.53%. Now we're asked to calculate the percentage of chlorine by mass in this mixture. Alright, so the way you want to do this is by finding the percentage of chlorine in NaCl, or finding how much chlorine there is by percentage in both NaCl and MgCl2. So here's the percentage. So we found the percentage of NaCl, 44.57, and then we're going to multiply by how much chlorine is in there. And then let's do the same thing for the mass, for the percentage of MgCl2. So you have 3.42 divided by 6.17. You get 55.43%. So there you go. Here's how much NaCl you have by percentage. This is how much MgCl2 you have. So and then multiply by how much chlorine there is in there, which is chlorine over NaCl. And then you do the same thing here, but you do Cl2 over MgCl2. So we have 35.45 divided by NaCl, which is 22.99 plus 35.45, and then multiply 44.57. So you get that there's 27.04% of the mixture is the chlorine in the NaCl, but there's also some chlorine in the MgCl2, so let's find out how much there is in there. That's going to be Cl2, which is 70.9 divided by 70.9 plus Mg, 24.31. So let's do that. You get 0.744-ish. Multiply that by your 55.43. You get 41.28. 41.28% of chlorine that is in the MgCl2. We add these up together, you get 68.32%. That's how much of the mixture is chlorine that's either in the NaCl or the MgCl2. And your last step, or actually no, you don't. You just leave it like that. If it was asking for the mass, then you would multiply this by 6.17, but since it's just asking for the percent composition, you leave it like this. 68.32% of the entire mixture is going to be chlorine. Let's move on to the second set of problems that I have set up. A student needs to analyze a mixture that contains BaCl2 and NaCl. The student dissolves a 6.75 gram sample of this mixture completely into water and adds an excess amount of Na2SO4. A white precipitate of BaSO4 is formed based on the following chemical solution. Calculate the number of moles of BaSO4 that is recovered in this experiment. So since we have a balanced chemical equation, for example, say you have 1 mole of BaCl2, that means that there's also going to be 1 mole here. There's going to be 1 mole of 2NaCl, which is 2 moles of just NaCl, and 1 mole here. Say, for example, you had 5 moles of BaCl2. This would be 5, this would be 10, this would be 5. Alright, all that to say, there's the same amount of BaCl2, which we're given the mass for, the same amount of moles as there is BaSO4. So all we need to do is find out how many moles of BaCl2 there are. And the way you would do that is 6.75, which is the mass provided, divided by the molar mass of BaCl2. Mass of Ba is 137.33, and then add 2 chlorines, which is 70.9. You get 208.23. So let's do the math. Let's divide now. 6.75 divided by 208.23 gives you 0.032 moles. Part B asks us to calculate the percent of BaCl2 by mass in the mixture. Alright, so all we have to do, the mixture is BaCl2 and Na2SO4. So BaCl2 is one of the 2 molecules in there. So we divide that by itself plus the other thing in there, which is Na2SO4. We just discovered that the molar mass of BaCl2 is 208.23. We get 208.23 plus the mass of Na2SO4, which is going to be 2 NAs, 45.98, plus sulfur, which is 32.06, plus 4 oxygens, which is 64. So let's calculate that out really quick. 45.98 plus 32.04 plus 64. That gives us 142.02, and then add that to the 208.23. That gives you 350.25. So now let's divide the 208.23 by 350.25. And you get calculate the percentage of BaCl2, which is 0.059. Or sorry, rather you'd have to multiply it by 100 first. So you get 59.45%. Now let's take a look at number 4. A mixture of CaCO3 and Na2CO3 is found to contain 35% Na by mass. Calculate the percentage of Na2CO3 by mass. So first, we have to find out what percent of the Na2CO3 is Na, or sodium. So the way we do that is we take the sodium and divide it by the entire mixture. And what you get is 45.98 divided by 45.98 plus 60.01. Let's see what that is. 45.98 divided by 45. Oh, you have to remember to put your parentheses when you have two numbers in the denominator in the calculator. 45.98 divided by parentheses 45.98 plus 60.01. Multiply that by 100. You get 43.38%. So if this is the percent of just Na, that means that 100% would be all of it. So what you want to do is divide 100 by 43.38 and then multiply that by the initial percentage, which is 35, and that should give you the percent of Na2CO3. Let's go. Let's do that. We can just simplify it to 3,500 divided by 43.38. That gives you a value of 80.68%. And the reason that this makes sense, and we can conclude that this is a logical answer, is because Na, as we have found, is slightly less than half of what is in Na2CO3, meaning that CO3 is just a little bit more, has a little bit more mass than Na2. So therefore, it would make sense that since it is a little less than half, the percentage of the entire molecule would be a little more than double. See, if you were to double 35, you get 70, and 80.68 is just going to be a little bit more than that. So yeah, there's a good explanation if you were struggling thinking about that logically. And that's all I have for you guys today. Hopefully the video was useful. Hopefully you learned something, and if you did, make sure to leave a like and subscribe, as this greatly helps the channel. And if you have any comments, questions, or concerns, leave them down in the comment section below, and I will try my best to respond to them. And have a great day, and I will see you guys next time.